Let's explore scale drawings. Page 1/5. Copyright 2022 Edmentum, all rights reserved. Scale drawings. Anil created a scaled model of the Eiffel Tower. His model is 24 centimeters tall. This is a scale of 1 centimeter equals 41 feet. How tall is the real Eiffel Tower? Page 2/5. Copyright 2022 Edmentum, all rights reserved.
Anil created a scaled model
Privacy
of the Eiffel Tower.
policy.
His model is 24 centimeters tall. This is a scale of 1 centimeter equals 41 feet. How tall is the real Eiffel Tower? To find how tall the real Eiffel Tower is, we can use Anil's scale model. When a scale has a unit of 1, like we have with 1 centimeter, we can use multiplication. If 1 centimeter is equal to 41 feet, then to find how many feet 24 centimeters is equal to, I can multiply 41 by 24. 41 feet times 24 is equal to 984 feet. We could have also solved this using a proportion. We know that 1 centimeter in his model is the same as 41 feet for the actual tower. Anil's model is 24 centimeters tall, so I will set 1 centimeter equal to 24 centimeters. I will use h to represent the height of the actual tower. In a proportion, the cross products are equal to each other. So I will multiply and set the cross products as equal to each other to determine the height of the Eiffel Tower. First, we will multiply 1 centimeter times h. Now, I will multiply 41 feet by 24 centimeters. Next, we will divide both sides by 1 centimeter to get h by itself. This cancels out the centimeter units and leaves us with 41 feet times 24, which means h equals 984 feet. Both methods show that the real Eiffel Tower is 984 feet tall.
Blueprint reading. To solve for a missing actual or blueprint measurement, set up a proportion. If the cabinet between the shower and the sink is inches wide on the blue with the scale. Blueprint reading. To solve for a missing actual or blueprint measurement, set up a proportion with the scale factor and solve. Example. The following blueprint of a bathroom has a scale of 2 inches equals 3 feet. If the cabinet between the shower and the sink is inches wide on the blueprint, what is the actual width of the cabinet? Solution. Let x represent the actual width of the cabinet. Set up a proportion and solve for x using cross multiplication. Therefore, the actual width of the cabinet is feet. Page 3/5. Copyright 2020. Scale drawings, real world. Large objects can be represented by smaller scale drawings. The proportions of the objects, or scale, must be consistent throughout the drawing. Example 1. The two drawings above are scale drawings of the same house. If the smaller drawing on the left measures 2 centimeters tall, how many centimeters tall does the larger house on the right measure? Solution. In the smaller drawing, each centimeter represents 15 feet, which is 3 times the amount that each centimeter represents in the larger drawing. So, it takes 3 times as many centimeters to equal 1 foot in the larger drawing than in the smaller drawing. This means that the larger drawing is 3 times the size of the smaller drawing. Multiply the height of the smaller house, 2 centimeters, by 3. Therefore, the larger drawing measures 6 centimeters tall. Example 2. If the area of the smaller rectangle is 10 square feet, what is the area of the larger rectangle? Solution. The length and width of the larger rectangle are 3 times the length and width of the smaller rectangle. The area of a rectangle is equal to the product of its length and width. See the calculations below. The area of the larger rectangle is 9 times the area of the smaller rectangle. This is shown in the figure below. Therefore, the area of the larger rectangle is 9 times 10 square feet, which is 90 square feet. Area using scale factor. When a figure is dilated, the number the length of each side is multiplied by is called the scale factor. Length, 2-dimensional. Rectangle A. Rectangle B. In the figure above, the dimensions of rectangle B are 3 times the dimensions of rectangle A. Therefore, the scale factor from rectangle A to rectangle B is 3. When an object is dilated, the area is multiplied by the square of the scale factor. Example area. Rectangle C has dimensions that are 3 times the dimensions of rectangle D. The area of rectangle D is 10 square centimeters. What is the area of rectangle C? Solution. First, find the scale factor. Rectangle C has dimensions that are 3 times the dimensions of rectangle D, so the scale factor from rectangle D to rectangle C is 3. Next, find the area of rectangle C by multiplying the area of rectangle D by the square of the scale factor. Therefore, the area of rectangle C is 90 square centimeters.